So in this series, we are going to be studying circle geometry. So before we get into any of the crazy circle theorems, this video will just be here to introduce the topic and give you a bit of a recap on some of the features of circles, as well as a couple of other key terms and definitions that we have to go over before we start the course properly. Now, a lot of this will be revision. We remember how to label, for example, a diameter, what a diameter is. We have a radius here, which you know. This part will be quite important because with a lot of our circle theorems, remembering that the radius is equal in all directions, it's going to be very important as we sort of go through with this topic. Now, concentric circles with a center O. So we just have these circles sort of going out from the center. This fourth one that we have intercept. So when the two lines cross each other, we have intercept AB, BC, and AC. These are just our different line segments. We have an arc. We remember that from earlier, as well as a sector. Now, a couple of new ones that we haven't talked about too much on this channel is we have what's called a segment. Now, when we have this chord that passes through here, it breaks up our circle into two bits. So we have what's called a minor segment, that's the smaller portion, and a major segment, which is the larger portion. We have a chord AB here. So it goes from one part of the diameter to another part on the diameter as well. And a secant goes through those points along not on the diameter, on the circumference. We're saying on the circumference of the circle here and here. We have the same thing happening over here. We have our circumference, and our secant cuts the circle and goes all the way through it. So we can see we have this bit on the end here and here for our secant. Couple more before we get into it. We have what's called concyclic points. So these are our points that lie on a circle. And when we connect these, as you see in this example next to it, we have what's called a cyclic quadrilateral. So it's a quadrilateral, a four-sided shape that lies on a circle where the vertices of this shape sit on the circumference of a circle. Now, here we have an angle at the center subtended by arc AB. Now, this word subtended is going to come up a lot, especially in these circle theorems. Now, just to give it a quick definition, when we say an angle subtends the line or arc, it means that its vertex, so the pointy bit, is where the rays that pass through the endpoints of the line segment or arc meet. So we're going to go into this a lot when we look at the circle theorems. Now, here we have an angle at the circumference, so an angle where the point is at the circumference, the vertex, and it's subtended by the arc AB. So you can see these rays here. Let's do a different color. These rays basically go from the arc to the vertex. And that's what we mean by if something is subtended. Now, we have here an angle here. This is what we call an angle at the center, which is subtended by a chord AB. So we can either be subtended by an arc, as we saw here, or by our chord, which is over here. And that's just the angle that's formed by the rays at those endpoints. We have an angle angle at the circumference subtended by chord AB. So we had center here. We have it at the circumference as well. I'll go through these a bit quicker. And we have the arc AB subtended by an angle at the center. And a couple of more features we're going to talk about before we get into anything afterwards is when two circles touch, they have a common tangent at the point of contact. So the point of contact where these touch, which is here, they have what's called a common tangent. Now, a tangent is a line that touches the circle at one spot. Now, if you look back at our secant, it basically cuts through. So it goes all the way through here to here. Our tangent is at the circumference and it touches it at one point. Now, a feature of two circles, when they touch, they will have a common tangent at the point of contact. That should be relatively intuitive as well. And when we label a tangent, so here, for example, we have this tangent going from here to here, and we call that tangent CBD because there's three significant parts to this. We have C and D as these sort of endpoints here, and B is the point of contact. So when we're labeling our tangent, we use the three letters there. Now, one more thing I'm going to quickly go over before, just to end this video, before we get into the theorems, is a word that's going to keep coming up here. Now, here, you will see this word converse coming up a lot. Now, just to define this, the converse of what we call a conditional statement is created by swapping the if hypothesis and then conclusion. So if something, then another thing. Now, if we say, for example, I'll write it here so you can kind of get a feel for it, and I'll give you an example. So if one thing happens, so if P, then Q, the converse to that statement is if Q, then P. So a good example of this is, for example, if two lines are parallel, they will not touch. Okay, so that's a sort of something we've been dealing with a lot. So if two lines are parallel, they do not touch. The converse to that would be if two lines don't touch, they are parallel. You can see we've just swapped the hypothesis, if something, and the then some conclusion part there. So we basically just swap those statements. So if two lines are parallel, they do not touch. If two lines do not touch, then they are parallel.